Hi all, welcome to another episode of Better Performance. In this episode, we are going to discuss the another design pattern, that is database. In this, since all the episodes are dedicated to performance, so we will understand that how we can read AWR for the performance. As you have seen the design patterns here, we have already discussed that we are having multiple design patterns like data management. So we will discuss onto this portion of the database. What is AWR? AWR is an automatic workload repository which is created by Oracle. It stores the different statistics which can help us in stopping the overload processes. We can tune the database and also tune the application, modify the services based on the priority, also implement the recovery scenarios which is required at the time of any failover. Let us understand in details that what AWR and how it works. So AWR collects all the different statistics like SQL statistics, load profiles, memory profiles, wait events, IO profiles, IO stats, segment stats, stream stats, operating systems stats, and also buffer stats. Once it collects all these stats, it creates a snapshot every hour. Once these snapshots are created, these are basically AWR ADDM snapshots, and we can use that. In general, AWR provides certain recommendations also based on a generic rule which is being into the industry has been into the practice. But these rules are not hard and fast rules which can be used. For example, if AWR says that we have problem at A place, so we cannot go directly and look onto the A place problems. A place could be a symptom, but others could be cause. So we have to understand the symptoms and root cause both. So in this episode, we will discuss more onto this, how we can understand the symptom, how we can understand the problems. So first, I am going to discuss onto the load profile. Load profile is one of the good stats onto the AWR which gives that information how my system is performing. If you look onto the load stats of four different AWR which I have presented over here, 1, 2 and 3, and last is the fourth one. In all the first three, you can see that DB time 1, 3 and 4 has lesser, whereas into the second, you can see that DB time is very high, which is 653 or 663 second is the DB time. What is DB time? DB time is basically sum of DB CPU and non-idle time. Let us understand what is DB CPU. DB CPU is a foreground and background processes which are being used are DB CPU. So how much time CPU is involved in processing foreground and background processes. Whereas idle time is whenever a process which is trying to execute something, it is sitting idle and waiting for any of the trigger or any of the work to be happened by the background process or a foreground process. Whereas non-idle time is that any process, either a query or a procedure, it is waiting for output to come because it can be stuck because of the network, could be stuck because of the IO, could be stuck because of the CPU. If all those combinations can come, it can be stuck over there and waiting for that process to come and serve that request to an end user. So this is a non-idle time. So DB time is sum of DB CPU and non-idle time. So we have to be cautious onto this. So let us understand that second AWR where you can see that DB time is very high. Note down this that this DB time, how we can relate it going forward with the different statistics. So here In order to do that, we have gone onto the SQL order by elapsed time. In this, we will see that there are certain procedures, there are certain PL SQL code which are executed and giving more of the time. You can see that elapsed time is very high. Executions is, let's say, close to 1 million, whereas it has a approximately 868,000 second as a elapsed time for this many executions. That means approximately 890 millisecond it is taking by each CPU, by each query. Whereas similarly, if we look onto the next one, it is also taking approximately 830 milliseconds per execution. Whereas the below one is taking 7.51 second to execute one query. That means all these queries are taking very high. Since we can see that within 1 hour executions is 971,000, that means it is a regular transaction processing. If it is a regular transaction processing, it should not be more than 20 or 30 milliseconds. That means somewhere we have something wrong. As I know, this database has a normal load profile where 70% is a read and 30% is a write, but onto the CPU, if we look, it is a more onto insert as a write, which is taking elapsed time. So if we go on to the next slide, we can see that SQL order by CPU time. Here again, we can see that highest CPU is being utilized by the insert queries, whereas certain select queries below having lesser CPU time is being used. So we need to understand that why this is taking so much. That means if any insert is taking time, it could be because of we don't have the sufficient amount of processing to be done, or our IO status really a problematic. So let us understand and relate onto this AWR how it is working. So I have taken the below stats onto the table spaces. I can see here that table indexes, the second one is a data, first one is the index. So both are taking use read and write. So if you look onto the read and write, which is high, write is higher than read. That means whenever it is going to write, this is taking time. So combination is giving the high CPU time, which has to be reduced. How it can be reduced? It can be by tuning the indexes, or also trying to have the appropriate indexes into the system. So in this case, I have seen this application personally and found that this has a global partitions. If it is a global partitions and number of indexes is also very high, it is approximately 8 or 10 different indexes are there with multiple columns, which is not required. So we can tune this entire table by putting the proper index. Once we will have the proper index, this will reduce drastically. Once this right portion is reduced, it and index is tuned, it read also reduces. So this is what to be done onto the particular insert queries. So in this, we can summarize the entire reading of this particular AWR that indexes are not proper. It has a global index, whereas it should be local index on partition tables. Indexes types are inappropriate, where bitmap and btree indexes should be properly defined. Since this is a OLTP database, so we should concentrate onto the OLTP performance and should have lesser indexes rather than having the higher indexes. Whereas OLAP databases might require a higher indexes or a use indexes to fetch the data effectively. Also, you can see here that commits and rollbacks has a very high percentage of active sessions. So you can see that 55% is going on to the commits and rollback. So if it is a commit and rollback is higher, and also onto the top SQL statements, this is a insert statements coming where IO and cluster is taking time. So if we can reduce this, my database performance will be drastically improved. So this is all onto this episode. Keep experimenting and better performing. In the next episode, I'll come onto some more insights about that, how we can create a better indexes like bitmap and b-tree indexes, or execution order of indexes that will help in giving us better performance of application as well as the reporting. Thank you.